All right, class, here's this data that we collected in class with that memorization exercise. So you remember how it went was I taught you that there was this paper that's been written a long time ago that most of us can only remember about 7 things, plus or minus a couple. And we had this hypothesis test that if I taught you a new sort of mnemonic, a new memorization technique, that you could remember more. And then the last thing we did in class was to show, using a one-sample t-test, that's what we ended up using, that I could show that I could teach you significantly more than 7. So we rejected the null hypothesis that the mean was 7, and we found a mean closer to 11 or 10 or something like that. All right, so I want to use the same data, but instead run a couple different two-sample t-tests, two-sample t-tests. The first one I want to do is to determine whether or not the right side of the class was better than the left side of the class. Right, so that one's pretty easy. So let's write out sort of a null and alternative hypothesis for those ones. So the status quo, nothing interesting is going on, is something like the left side mean equals the right side mean. Right? The alternative is, I don't really know which one's better or not, but we could just say that they don't equal. All right, so I'm just going to write does not equal the right side. So right away, if I don't know, whether one is sort of going to do better than the other, I just think, well, they're going to be different. Different is not equal to, so that makes it a two-tailed test. That's what we're thinking of, right? So we learned we should probably rewrite these so that it's something more that has something that's got some math in it, right? So like an actual number. So if I take the left side and subtract the right side, it should be 0. That's what the null hypothesis says. But does not equal, then same thing. If I take the left side and subtract the right side, right side mean, then it does not equal 0. I don't know how to do does not equal. That also means does not equal. So if I put the sort of greater than and less than, like they're eating each other, that means does not equal as well. So we'll do that. Okay. So there's our null alternative hypothesis. This is a two-tailed test. Two-tailed test. So there's step 1. Done with that. So step 2, go collect some data and calculate a test statistic. So we got the data. Let's do this. I haven't done this yet. Let's just sum up all 3 of these guys so that we know how many. So this is total words remembered. Total words remembered. All right. So I did that with everybody. We're going to let Excel actually go and calculate the actual test statistic. But a test statistic is just a t-value, right? In this case, though, the t-value is not as straightforward. We're going to have to figure out sort of how much the means differ from one another, and then how far away is that from 0 in terms of some standard error. So it's the same thing we did with a one-sample t-test. The standard error calculation, though, is a little bit complex. If you want to know more about the standard error calculations, you can go look on Chapter 13, but we're just not going to have time to learn it in this class. And instead, we're just going to let Excel figure out the standard error calculation, and it will just spit out a p-value. We will get a t-score as well, a t-test score, and then it will spit out a p-value for that t-score. All right, so that's what we're going to do. So before we do that, though, let's set a level of alpha. So let's just make an alpha of 0.05. All right, so finally we just need to figure out a p-value. So in order to do this, in order to do a two-sample t-test, we actually have to separate the data so that we have one column for the right side and another column for the left side. So let's just do that. I'm going to insert a couple more columns here. So let's call this the left and call this the right. Easiest way to do this then is to just sort the data. All right. So here's all the left. The left is now sorted to the very top. So if I can just scroll down here until, so here's where it starts becoming right. So everything above that is the left side. So I'm going to just copy that, Control C, and then put it right here, Control V. It didn't work, did it? Oh, I know why. We actually have to paste the values. Remember, this is like a formula, so it's doing this sum thing. So by copying it over, it just like moved the whole formula over. So instead, what I'm going to do is say paste, and then this little thing is values. Paste the values. So now I have the real numbers. So that's what I want. Okay. And now for the right side, Control Shift down, Control C, go over a couple, come back up. I'm going to have to do the same thing, paste values. All right. See, make sure I got that right. Yeah, that looks right. Now, one thing to notice, look, there are actually a handful more people on the left side than there were on the right side. And that's okay. That's not a problem. It's okay to have a different sample size for each of these. We consider these two separate populations, the left side of the class and the right side of the class. And so really we're sort of testing this hypothesis that people who sit on the left side of the class and people who sit on the right side of the class end up doing differently when it comes to this memorization thing. I don't really know what the answer is. I haven't tried it yet, so we'll see if there's anything there. But intuitively, it doesn't make much sense that it would be different. In fact, my guess, and I could be wrong, but my guess is we won't have enough evidence to reject this null hypothesis. Right? Okay, so let's give it a shot. So now all we do is we go into, well, before I do that, let's look at some of our notes. Hopefully you just watched the notes. So there's this little this guy that's going to tell us what we're supposed to do. So this, you should starting to use this little thing. First thing we ask is, are the samples paired? Really, another way to think of that is we have two different populations, really two samples from two populations, and we want to know, are they paired? And by paired we mean, do they belong to the same person? So, or the same thing, or something like the same company, or something like that. In this case, well, not really. I mean, we have left, this is one group of people, and right is a different group of people. This 8 and this 6 don't really belong to each other. There's no reason to say that those two need to be next to each other. We could sort one of these and the other one, it wouldn't make any difference. So we'd say, no, this is not paired data. In a second, we're going to do one that is paired data, but this is not paired data. All right, so if it's not paired data, screwed something up. Then we go down this little route here. We say the first thing we have to do is find an f-test 2 sample for variance. And the reason we do this is to figure out whether or not we should use equal variance or unequal variance. All right, so we're going to run this. It's going to spit out a p-value. That's not the p-value for our original hypothesis. It's just a p-value to tell us whether or not the variances between these two populations, between the left side and the right side, are the same, roughly the same, essentially. If they're roughly the same, then that just changes the way we calculate the standard error. That's all it really does. So there's a difference between the way we calculate the standard error for these two, so we just need to figure out which one to use. So we first run this. If the p-value for here is really low, then we say, assume that the variances are unequal. If it's not low, then assume that they're equal. So let's do that. All right, so we go to data analysis, and we scroll to the bottom. Oh no, f-test is... There it is, f-test 2 sample for variance. Click on OK. Variable 1 range, that's our left guys. Hit enter. Variable 2 range, that's our right guys. Hit enter. We got labels in the first. Yeah, alpha 0.05. Let's put it in a new worksheet, that's fine. Click on OK. That's it. All right, so this gives us a bunch of things. It gives us a preview of sort of the mean. So the mean on the left is 10.8, the mean on the right is 10.5. So that's not that, that doesn't seem that different. Here's our variances. So the variance on the left is 9.9, the variance on the right is 6.25. So they might be a little different. But here's our p-value down here, p-value of 0.08, right? So it seems like it's actually getting kind of close to being different, right? Being unequal. One is 9.9, the other one is 6.2. But it's not enough. It's not enough to say, yeah, for sure they're definitely different. This could have happened by some random chance. In fact, there's an 8% chance that this could have happened randomly. And since our alpha is 0.05, we don't think that's enough proof to say that it's not happened. So again, back to our sheet here, we say, is the p-value of this f-test low? And by low, we mean lower than alpha. Lower than alpha. In this case, we set our alpha before we started at 0.05. So no, it's not lower than alpha. It's 0.08. So we assume equal variances. So we got to go back and do this t-test assuming equal variances now. So remember, this is not the answer. This just tells us which test to use. All right, so now we come back here and say, now we know we need to use the t-test for equal variances. So now we go to the bottom, data analysis, t-test assuming equal variances. There he is. Click on OK. Here's our left. Enter. Oops. Didn't like that. Here's our right. Enter. Hypothesized mean difference. What does that mean? All right, we're always going to put essentially 0 in right there. I'll show you in a second. I can't show it to you, but when we come back to our null and alternative hypothesis, actually, let me show it to you. Yeah, hit cancel. Let's look at our null and alternative hypothesis. Here's our null. Left side minus the right side equals 0. So there's the number that we think that's going to be different. Now, you could make that number something else, but in reality, it's almost always 0. But you could say 5 or 3 or something. The null hypothesis could actually say that there should be some amount of difference between these two. In this case, there isn't. There shouldn't be anything different. It should be 0. That's what the null hypothesis says. All right, data analysis, 2-sample t-test assuming equal variances. There's our left. Make sure we get that right. Here's our right. Hypothesized mean difference is 0. We got labels in there. Let's put a new worksheet. We're good. Fire away. All right, so again, here's our means. Here's our variances. We have 40 on the left side and 35 on the right side. This is a pooled variance, which is essentially kind of a weighted average between these two variances. There's a formula specific for it. It's in the chapter 13 of the book. Hypothesized mean difference. Here's our degrees of freedom. Again, there's a formula for that thing. And here's a t-statistic. So what this is really saying is that you expected it to be 0. It's not quite 0. In fact, we can figure out what it is. The difference between those two is what? 0.31. 0.31. It's supposed to be 0, but you actually got 0.31. How far away is that in terms of standard errors? We don't have the standard error in here, but it's really just this pooled variance divided by sort of the square root of there's a formula for it. I can't remember what it is at this minute. Anyway, here's the t-statistic. That's just like a z-score. It tells us how far away 0.31 is from 0 in terms of some standard error, which isn't very far. We say that already. That doesn't seem very far. We got two p-values here. These two right here. So here's a one-tailed p-value and here's a two-tailed p-value. We started at the beginning and said this is a two-tailed test. 0.641 is our p-value. That's not very high. In fact, that's not very low. It's really high. It's really high. So we say, since the p-value is not lower than alpha, which is 0.05, we do not have enough evidence to reject the null hypothesis. All right, so essentially what we're saying is, I'll go back to this. There's really no evidence to say that there's a difference between the left side and the right side of the class, which makes sense. I mean, why would it make any difference? You guys are all just equally as geniusly brilliant. It doesn't matter where you sit. I mean, there are differences between you, but the randomness of where you sit and what class you're assigned and all that kind of stuff shouldn't make too much of a difference between the left side and the right side, and we found out that it didn't. All right, so here's the next test I want to do. I want to use the same data. So if you take a look at how I asked you to report what you saw, I asked you how many of the first 5 words you could remember, how many of the middle 10, and how many of the last 5. Some of the research that I do is about the phenomenon that we tend to remember things that happen to us at the end and also at the beginning better than we do in the middle. So I want to come up with a hypothesis about that. So in fact, I'm going to copy those 3 columns and start a new sheet just because this sheet's a little dirty now. I've got lots of stuff on it. So here's my null hypothesis. Sorry, let's start with an alternative hypothesis. My alternative hypothesis is that we tend to remember, let's see, the beginning and ending more than the middle. That's what I want to prove. That's what belongs in the alternative hypothesis. That's what I'm trying to prove. The null hypothesis is nothing interesting is going on. We remember everything about the same, right? So something like we tend to remember beginning. I liked it better when it spelled it right for me. Beginning and ending the same as the middle. But I mean like the words in the middle, right? So as opposed to the words in the beginning and the end. So before, I'm going to write this out in math in a minute, but let me kind of tell you what I mean, what I'm going to try to do here. So let's call this the middle. Let's see. The beginning and the end. And this one is the middle. So the beginning and the end. So that's the first 5 words plus the last 5 words. So that person remembered 6 of the beginning and the end. And then the middle, they remembered 2. Both of these, they had 10, right? Because there was 5 in the beginning, 5 at the end, and then there's 10 in the middle. So this person, if I just looked at this one anecdotal evidence of this one guy, then there's evidence for my alternative hypothesis, right? So this is what we're after. So how do I rewrite this? Well, the null, I would say something like, let's see, the middle minus the beginning and end is less than 0. All right, could do it that way. The alternative is the middle minus the beginning, not the beginning and end is greater than 0. So remember, I actually already screwed up. First of all, beginning. Thanks for being patient on my terrible spelling. Beginning is less than or equal to 0. And in this case, the middle minus beginning and end is greater. Is this right? Let's see, make sure. So say the middle average was like 6, and the beginning and end was like 10, which seems crazy. That number minus that number is -4. Yeah, less than or equal to 0. Oh no, so I screwed it up. So it should be the other way around. So this is greater than 0. And I hypothesize that it's actually less than 0, meaning the beginning and end are bigger than the middle. All right, hopefully that didn't confuse you too much. But I'm testing, I think the beginning and end is going to be bigger. That's what I'm trying to test. Beginning and end is going to be bigger. So here it is. I'm actually ready to do it the way I've set it up. Let's go back to our little picture here and say, is this data paired? Is this data paired? The way to think about that, a couple ways to think about that is, does this 6 and this 2 belong to each other? The answer is actually yes. That's the same person. 6 and 2. Like that person remembers 6 at the beginning and then 2 in the middle. Even though there's essentially 2 populations, because the population of the beginning and end words and the population of the middle words. But it's the same person, 6 and 2. So this is paired data. Paired data. All right, so that's how we think about paired data. So that's it. So in fact, if we look at paired data, the paired data path, we don't have to do this f-test. We just go right down to t-test paired to sample for means. We don't have to do this guy in the middle. So we just go do that. So let's do that. Here we go. So data analysis, t-test paired to sample for means. Click on OK. Beginning and ends, our first guy. Variable 2. Middle is our second guy. By the way, notice for these paired sample, there has to be the same n in both of these, right? They have to be the exact same number of people, or number of observations. If there's not, then it's not paired data. That's one way to think about it. If it's not the same number, n, then there's no way it could be paired data. So if that's easy. Hypothesize mean difference, I think the null hypothesis is going to be 0. Here's my label. Yeah, check label, new worksheet. Yep, click on OK. Oh, what did I do? All right, I did something goofy in here. Let's look at this. Oh, there's some. Oh, yeah, this guy. Whoops, we forgot to fix this before. 3, 8, and 2. So in the middle here, if you're following along, you're going to have to go change those 3 numbers. Okay. Do that again. I got faculty meeting in 11 minutes, in case you're wondering. 2 sample paired t-test paired 2 sample for means. Click on OK. Yeah, I think everything's ready to go. Click on OK now. And here's we go. Let's see if we got this one. See if it actually worked this time. By the way, is this a one-tail or two-tail test? Let's go back here. It's actually a one-tail test, right? Because we actually really think the beginning and end are more, right, than the middle. So first of all, let's see if that's right. The middle, yeah, I got the beginning and end is 5.92. So that is more than the middle, which is only 4.9. So we essentially want to see, are those two things actually really significantly different from one another? Is 5.92 really different from 4.93? Here's the variance of the two. We have a Pearson correlation between the two. Hypothesized mean difference is 0, degrees of freedom of 7. A t-statistic, yay, we know that is a 3.52. That's a pretty big t-stat, right? So bigger than 3, we'd say pretty unlikely. So again, what it's really testing is to say how far, remember here's middle minus the beginning, negative 9.8. You expected 0, but you got almost negative 1. Nearly negative 1. How far away is that in terms of standard errors? Well, 3.52 standard errors away. That's a lot. That's a lot. So what's the probability of that happening randomly, which we call a p-value? Well, for a one-tail test, it's 0.0003. So there's our answer right there. Highlight that guy. And we say, since the p-value is low, so really lower than alpha, which was in this case 0.05. We could have it's actually lower than 0.01, so you could write it that way if you'd like. It's really low. Then we have sufficient evidence to reject the null hypothesis. So what does this say? This means we have evidence that we tend to remember beginning and end words more than the middle words. Cool. So I've done this now for about 3 years, twice a year. It's like the 6th time I've done this. Every single time it works out this way. All right, where we're always remembering the beginning and end more than the middle. It's not like a lot more. It's about 1 word more. But we tend to remember those beginning and the ending words more by about 1 word than the middle. So that's kind of interesting. All right, so that's it for this video, just to walk you through a couple stuff and to play with this data one more time. Okay, that's it. Off to faculty meeting.